So last time when we met, we talked quickly, I brushed through the system of equations. We talked about system of equations. We talked about how to solve system equations. Okay, I want to talk about the graphical relationship with solving of those equations. Okay, so let's say that I gave you a system of equations that looks like this. Let me ask you to solve this. Okay. So we talked about this. There are two ways to solve this, correct? There are two ways to solve this. In this case, which one would you use?
Put the y by itself.
Huh?
Put the y.
Yeah, so you would use substitution. You would solve for y, then you would put it in there because y is to solve for y is a simple one step of moving this over. You're going to get this, and now you can put that straight in there, right? Okay, so if I do that, I'm going to get 3x. This is called substitution, by the way. So 2, where y is, I put this guy in. This equals 8. So I'm going to get 3x. Now I do this, I get negative 4x. I do this, I get 10 is equal to 8. So now I'm going to just collect all the x's and then the constants on one side. So I'm going to go ahead and do this. Negative x, move the 10 over. Negative 2. Okay, all right, we're good here so far. So x is going to be equal to 2, obviously. So x is going to be equal to 2. I put that guy in here. I get negative 2 times 2 plus 5. That's going to be y. So this is negative 4. Y is equal to 1. So this is what I would get. So yeah, go ahead.
X is equal to 2, but it says x is equal to negative 2. How did we get to that point?
We just multiply both sides by negative 1.
Oh, yeah, I see it now, sorry.
Okay. All right. Again, if I go too fast, stop me, okay? Good question, good thing. Okay, so x is equal to 2. X is equal to 2, y is equal to 1. Okay, so how would let's say that I had a lot of time and I'm going to go ahead and see if this actually works. How would I do that? How would I verify my answer? How would I verify that this indeed is the answer?
Just plot both lines and see if that's what.
Okay, that's one. But the most easiest way would just to put them in, right?
Yeah.
So it'd be 2 times 2 plus 1. If I did that, I get 5. That's good. 3 times 2 plus 2 times 1, 6 plus 2, 8. So it indeed works. Okay? So now let's talk about what he just said. Let's go see what happens. What does this actually mean? What is this graphically saying? From a graphical standpoint, what's happening? Okay, so we have two. So I'm going to go ahead and graph both lines. Okay? So let's see if we can graph both lines. So the first one, I'm going to go ahead and say, well, this is pretty darn easy, right? I just moved the 2x over again. To graph this is in what form right now?
Slope-intercept.
This is in slope-intercept form, which means that this guy is the y-intercept. This is the slope. Negative 2 is the slope. Okay, so so if I were to graph this, I get 5. Right, I start at 5, and I know this is the one, if this goes to this point, how would I graph a negative 2 slope?
Would you start from 0 and...
Well, I can't start from 0, I have to
oh,
start from here.
From 5.
And then I do what? I go over 1,
Down
2, correct? Over 1, down 2, over 1, down 2. And I would carefully connect the dots. So this is the graph for y is equal to negative 2x plus 5. Now this guy here, I have to do a little bit more work. Because now I'm going to do what? I'm going to move the 3x over. I'm going to get 2y is equal to negative 3x plus 8. What's my next step? I want y by itself, so I'm going to divide everything by 2, correct? So it's divided by 2. I'm going to end up with this. correct? Okay, so again, I'm in slope-intercept form, which I want to be. This one starts at 4. So instead of 5, I'm going to start at 4. Now I have to graph this. How do I graph this?
Over 2, down
Over
3.
2,
Down.
down 3, right? Over 2, down 3. Okay, so hang on a second, where am I at? Okay, so 2, 2. So actually it's going to be over here, so I'm going to go end up like that. Okay, what I just did is this. So this guy here is what? This guy here is 2.5. Can you see why that's 2.5? Because if this was y is equal to 0, I didn't want to reach the x, correct? So then I would move the 2x back over. I have 2x is equal to 5, x is equal to 2.5. So this would have been 2.5. By the same token, if I did this one, this goes to 0. If I divide everything this by 3, what do I get? I get 2.66666. So it's going to be on this side, right? So it's going to be right here. So this is the point where it's going to meet. And if I went ahead and did this correctly, this point is going to be what?
2, 1.
2 and 1, right? Because that's where it says that I meet, right? Because this point satisfies not only this graph, or this line, it satisfies this line too. So it has to be on both lines, which means it's going to be at the intersecting point. Okay? So now do you understand what that meant? What it means when they are the same, or it satisfies the equation. So therefore, if I gave you an equation that looked like this, and the other one was this, you could say what? So let's forget about this one now. If I gave you this, if I plot these, what do I get? I'm going to get, on the first one I start from 1, 1, 2, 1, 2. It'll look like this, right? So this is this guy here. This guy here is going to start, instead of 1, it's start at 2. 1, 2, 1, 2.
So they're parallel.
They're parallel, right? Because the slopes are the same. Now you see when they're parallel, when the slopes are the same, in this fashion, they are never going to meet. Correct? So the answer to this is going to be, there is no answer, right? There is, I guess, there's none, right? There's no answer, right? Because they never meet, right? Okay? If I gave you the same line, what would happen? And the lines would be right on top of each other, right? And any point would work because you have infinitely many solutions, right, at that point. Totally different, right? Ones were none. When they're one on top of each other, then they are going to be infinite amount of answers, right? Now, I mean, one of the ways that people like to trick you is that they would go this and they would say, like that. They look different, but they're the same because if you divide this by 2, you get this guy, right? They're the same exact equation, correct? Okay? Right? Okay. Good. So that's that. So that's what it means. So that's actually what's happening graphically when you solve a system of equations. You're going to plot 2 lines. You're actually plotting 2 lines and finding where they meet. Okay, although algebraically you're just plugging and chugging, you're going through the motions, right? And mechanically you know what you're doing, but graphically that's what's actually happening. Okay? All right. So that's good. So that was the point of intersections. We talked about the midpoint. Parabola. Okay. Do we have your calculators? Can you go ahead and plot these for me, please?
I don't have my calculator today.
Don't have your calculator today. I cannot guarantee you on the availability of the batteries, but hey, they're calculators, so they see if they work. I don't know if they work or not.
Thank you.
That's probably, I don't know, one's probably not gonna work. No,
You can, I can use the
okay.
sign, I mean, obviously not on the actual SAT, but for now.
Thank you.
Phone.
What's there on the other piece of paper?
Flat piece of paper, yes. On top of the file cabinet, you see that stack of paper? Well, that's all scratch paper. You can take as many as you want. So we plotted it. Hopefully, this is what you got. Did we get this? So we kind of talked about this the other day. When we talked about y is equal to a squared plus b squared plus c, right? We talked about that, what the a was positive, c was negative, nothing, all that kind of good stuff. Okay? So, you guys are not gonna remember that? You guys haven't been taught this yet. Or maybe you have, I'm not sure. What is this point called, Grant?
That's a vertex.
This is called the vertex, correct? This is the vertex. So this equation, or this parabola, has a vertex of 1 and 1, right? Okay, which means that it's going to be always greater than y is always going to be greater than 1. Can never be less than 1. Okay, that's one thing we can say about this. What else can we say about this? If I ask you to solve this, when does this happen? When is y equal to 0? Trick question, right? Y can never be equal to 0, right? Because y always has to be greater than 1, right? In other words, there are no roots to this equation, okay? There are no, does never intersect with the x-axis, okay? So, how do we go from here to finding out what the vertex is? Okay? The vertex form of an equation looks like this. Like this. That's what it's going to look like, okay? So in this one, can anybody tell me what my A would be? What would A have to be here? Because if I did this inside, what do I get? I would get x squared minus 2hx plus h squared plus k, right? So if I do the a out, I would get ax squared. That's the only x squared I'm ever going to get, and it has to look like this.
Which is 1.
So a has to be 1. Do we understand that? Do we see that? A has to be 1, right? Therefore, a has to be 1. So I know that a is going to be equal to 1. Okay? So I have to make this guy somehow look like this. Okay? Right? This is one of those things that you've been taught before. something that always people forget about, and they really don't kind of get it because it's called completing the square. Have you heard this term before, Grant?
Mm-hmm.
So we're going to complete the square. Completing the square means that I want to make this guy look something like this. So, in order to get negative 2x, since I know that a is equal to be 1, I can get rid of this. Right? As far as x's go, I have what? Negative 2hx, and that has to be equal to negative 2, correct? That's the only term that I have that has x in it, right? So in order, if I do that, oh, not x, 2h, right? Negative 2h. So I'm putting the constant in front of it, right? So that way, if I do this, I divide both sides by negative 2, h is equal to 1. In other words, this is going to be equal to x minus 1 squared something or another. Okay? All right. So if I just do this part out, what do I get? I get x squared, get negative x, negative 1x, so it's going to be negative 2x plus 1. Right? So if I can rewrite this guy as what? I can rewrite this guy now as everybody see that? Why do I put this guy in the same parenthesis? Because this guy is the same as this guy. In other words, this is going to be equal to x minus 1 squared plus 1. Okay, remember we talked about the h and the k here? So h would be 1, k would be 1. So that's the vertex form because this is the vertex of h and k. Okay? All right. So that's that. Another thing that we need to talk about is this guy. What is this guy called? This guy here? Axis of symmetry, because obviously it is symmetrical across this axis. Okay? Axis of symmetry is going to be x is equal to 1. In other words, it's going to be the h value here, which makes sense because the vertex lies on this thing, right? Because this is, the coordinates here are going to be h and k. So the x coordinate, which is this line, is the same thing, x equal to 1. Okay? All right. So that's the axis of symmetry. Okay? All right. And so we're going to do the factoring. We'll do some of the factoring next hour. Okay, that's the one thing I want to cover. So you guys can, you two ladies can get a heads up or ahead of the curve and a little bit of review for you. Okay? So that's that. So that's the factor. We have not talked about the factored form. We'll talk about the factoring second half. So we talked about the vertex form. We did do the equation of a circle, so we're good with that. All right, now let's go to page 372. Page 372, we're going to do some geometry. Kyler should be a whiz at this because you had my class. So geometry on page 372, if you look there, there is a sheet there. And if you remember on the practice test, they gave you that sheet. So everything that's on that sheet is something you do not have to memorize. Okay? All right? Remember that. So the only thing, so what is the magic number? What was the magic number, Kyla? Number 1/3? 1/3, okay. 1/3. In geometry, the magic number is 1/3, and 1/3, the reason why that is the magic number is because if I have cylinder and a cone with the same radius and the same height. This guy exactly 1/3 of the volume of this guy. It doesn't matter if there's a circle on the bottom, if there's a triangle on the bottom, if there's a square on the bottom. It's always going to be exactly 1/3 of what this guy was. Okay? So if I had a, let's say I had a square pyramid, looked like this. Okay, this was A, and this was A, and the actual height was H. How would I calculate the volume? It would be the base area. Since I told you it was a square, it's going to be A squared, correct? A times A, because that's the area of the base. It would be A squared times the height times the magical number, right? 1/3. Okay. So the pointy thing versus the straight thing is going to be always going to be 1/3 the volume of what it was. Okay, so that's the only number. That's the real number that you have to remember. Quickly look over the volume there. Is there anything there? Are we all good with that? You all good with that? Okay. Now let's talk about the special triangles, special right triangles. There are two special right triangles, right? One is the 45, 45, 90. We'll do that one first. If this was 2, and this was 2, right? Now there's the two legs. This guy is called the what?
Hypotenuse.
Hypotenuse, right? So this is the two legs, this is the hypotenuse. What would the hypotenuse be? How would I calculate the hypotenuse here? C squared is equal to 2 squared plus 2 squared, correct? So 4 plus 4. C is going to be the square root of 8, because C squared is 8. So C is going to be the square root of 8. 4 times 2 is 8. Square root of 4 is 2. 2 root 2. So this is going to be equal to 2 root 2. And this ratio stays the same all the time. If you have a 45, 45, in other words, if the two legs are the same, they're always going to be the same. So in other words, if I had 4 and this guy was 4, what would this guy be? Just 4 root 2, right? Because it was 2, 2, 2 root 2, 4, 4, 4 root 2, right? In other words, this was A and this was A. This guy here is going to be A times root 2, right? Okay, all right. So the way, the trick question that they like to ask is, what if this guy is 4? What is this guy? What is A? So it would be 4 divided by root 2, correct? Because if this was 4 divided by root 2, when I multiply this guy by root 2, I get 4, correct? Right? Okay. And this is the same as, I multiply top and bottom by root 2. On the bottom, I'm going to get 2. 2 root 2. 2's cancel out. Root 2. Which makes sense, right? So this is root 2, right? Root 2 times root 2 is 4, which it should be, right? Leg times this times root 2 should be this guy, right? Okay? Okay. So that's the first one. What's the second one?
30, 60, 90.
Yeah, so I'm gonna have 60, 30, 90. If this is 1, this is 2, this is going to be root 3, right? This squared is 3, this squared is 1, add them together you get 4, the square root of that is 2, right? So this b squared, this guy's gonna be, this squared is this squared plus this squared, right? Same thing, if this was 4, this guy would be nothing more than that times 4, which would be 8. This would be that, right? Okay, because the ratio stays the same. The ratio always stays the same. If you look at that, and you can see that on that sheet there. Okay, they're using X's and S's. Okay, all right. So that's that. I'm not going to go over the trig stuff because it never comes out on the SAT. Okay, talk about vertical angles. We already talked about vertical angles the other day. Oh yeah. And there's the two lines, two parallel lines cut by the transversal. Do that. Then you have 1, 2, 3, 4, 5, 6, 7, 8 different angles. Angle 1 is the same as what angle?
Angle 7.
Angle 7. What else? 4.
And 5.
What else? And 5, right? 1 and 4 are the same because they are, we just talked about the vertical angles, right? They're vertical angles. Same as these two are vertical angles, these two are vertical angles, these two are vertical angles. 1 and 7 are the same. These are called exterior because they are exterior to the lines, exterior alternate angles, okay? And then we have interior alternate angles, right? Interior alternate angles, right? 4 and 5. 3 and 6, they're always the same, okay? And then we have what is called corresponding angles. Anybody tell me what the corresponding angle to number 1 is? 5. Number 5 is corresponding angles. 2 and 6 are corresponding angles. 4 and 7, 3 and 8 are also corresponding angles. Okay? All right. Quick trip through memory lane there. Okay, so that's good. What else should I talk about? That. Degrees to radians. Does anybody tell me what the relationship between degrees and radians is? Anybody?
It's 180, right?
Yeah,
180
so
and pi.
360 degrees is the same as 2 pi radians. Okay, right? Okay, which means that 180 is equal to pi radians. You guys have not taken trig yet. You've taken trig before, right?
Kind of. We got,
Okay, all right. So you had trig before, so
Well, yeah.
you were drilled into the unit circle and did all
Yeah, that
this
was
conversions and all
last
that
year at
stuff.
pre-calc.
Right.
It's like pre-calc.
Okay. Yeah. So just know this. Okay. Pi radians is the same as 180 degrees. In other words, if I go from here and go all the way around, that's 360 degrees, and that is the same as 2 pi radians. Okay? we talked about that. Special right triangles, talked about that. Circles. There's nothing much to talk about here. Okay. Anybody tell me what the area of a trapezoid is? Is that on your sheet? Area of a trapezoid on the geometry sheet? It is not.
Is it base times height divided by, no, never mind, that's a triangle.
You're close, you're close.
That was a triangle.
So if I have a trapezoid like this, or this guy's parallel to
Yeah,
this,
base one.
base one, base two,
Height.
the height. So what's the area?
Base 1 plus base 2 times
Or base times,
Base one, base two divided by two is the area. Okay? And I explained this in my geometry class, but I'll do it one more time. The reason why this works is if I took this trapezoid and I flipped it over like this and put them together, you're gonna get something that looks like something that looks like that, right? What shape is that?
rectangle.
Not a rectangle,
Sorry.
right? It's a
Sorry.
parallelogram, right? It's a parallelogram at that point, right?
Yeah.
Because this is gonna be B2, this is gonna be B1, right? So I have two equal lengths, B1 plus B2, B1 plus B2. They're parallel with a height of h, right? So the area of this parallelogram is gonna be B1 plus B2, this guy times the height. Right? Therefore, the trapezoid is 1/2 of that, so the trapezoid area is going to be that. Right? Okay, so you really don't have to memorize it. Okay, you could kind of finger it out if you had to, like this. Okay? All right? Okay, so that's that. Triangle. What kind of angles are there by angle measure? What are the, how do we classify the angles?
Obtuse, acute.
Obtuse and acute, right? Obtuse meaning they're greater than 90 degrees. Acute meaning they are less than 90 degrees. Acute means what? Outside the math world, what does acute mean? If I have acute pain, what does that mean? I have sharp, really pointy pain. That's what acute means. Does anybody know what obtuse means? Look it up. Look on your phones. Go to your phones. Look up what the definition of obtuse is.
Just like general, like more, specific.
Annoyingly insensitive or slow to understand.
Annoyingly stupid. That's what obtuse means, okay? So, have you guys watched a movie called Shawshank Redemption?
Oh, yeah.
There's
Watched
a,
it.
did you guys,
Religion.
you've seen that movie? You haven't seen the movie?
That's,
Shawshank Redemption?
I thought,
You haven't seen Shawshank Redemption? There's a part in that movie where the guy, it's Andy, the guy who's jailed, goes, talks to, when he's talking to the warden, he says, "How can you be so obtuse?" Okay, anyway. Okay, so we are done with all the material. I have went through all the material that needs to be reviewed. Okay, so let me go ahead and let's take a